The standard approach to building a massive chest typically relies on moving heavy weight as explosively as possible. At 25, the body can generally manage the stress of that extreme mass and motion. By the 50s and 60s, tendons lose elasticity. Collagen fibers within the connective tissue stiffen, which reduces their ability to act as shock absorbers for heavy moving loads. 60-year-old Rocky Ingram maintains peak chest hypertrophy, yet avoids bending barbells or relying on explosive movements. This raises a question about muscle architecture. How do fibers continue to grow when massive external loads are removed from the training equation? Maintaining muscle at this stage involves a shift away from tonnage toward mechanical control. Load selection starts with a weight that is comfortable to handle. This allows the lifter to dictate the terms of the movement. This diagram shows the forces acting on the shoulder joint.
Sudden deceleration at the bottom of a rep creates shear stress that aging ligaments are not designed to absorb. A flat, close-grip dumbbell press bypasses that stress. Pressing the weights together creates lateral pressure, forcing muscle recruitment without increasing downward gravitational load. This inward squeeze increases mechanical tension, the primary driver of hypertrophy, by extending the muscle's active duration. Maintaining this tension requires a controlled pace. Rather than letting momentum do the work, you lower the weight slowly to keep the muscle engaged through the entire rep. You can further manipulate this tension by varying the rep targets. Cycling through sets of 8, 12, or 15 fatigues different fiber types without requiring a heavier rack. Mastering time under tension allows a lifter to simulate the hypertrophic stimulus of a heavy weight with a fraction of the actual load, protecting the joints while encouraging growth. After establishing tension, the next step is achieving fatigue across every plane of motion. Transitioning from free weights to body weight movements, like incline and decline push-ups, removes the risk of a heavy weight crashing down on a fatigued joint. Body angle targets specific zones. Decline focuses on the lower chest, while incline biases upper fibers. Moving hands closer alters the body's lever arm, shifting the fulcrum to increase load on triceps and inner chest without added weight. The floor acts as a safety mechanism. If the muscle fails during a push-up, the physical risk is minimal compared to failing under a barbell. High-volume sets of 15 reps help achieve blood pooling. This completes the pump necessary for the muscle to fully fatigue. Combining controlled dumbbells with varied push-up angles results in muscle exhaustion without risking structural failure. Longevity in training depends on prioritizing the quality of control over the amount of weight on the bar. Dropping the ego at the gym door is a biological necessity after 50. Avoiding injuries that halt progress is the most effective way to preserve muscle mass. This methodology protects tendon health and joint longevity, allowing for consistent training over several decades. Lowering the weight to focus on the squeeze represents a transition toward an efficient form of physical maintenance. Lifelong strength comes from adapting to the body's changing mechanics and maintaining control over them.